to find the, or how to verify the sine of an half angle. In this video, we want to figure out the cosine of the half angle. Guys, in the previous video, I already actually wrote the identity of for the sine theta over 2. In this, I already know what the right hand side is, what the identity is, but in this case, let us actually just find out what the identity is. Guys, the process is going to be similar to what we used in the previous case. So like what we did in the previous case, we started with the cosine of a double angle. So I'm going to rewrite that. So we know cosine of 2 theta, and you know cosine of 2 theta has 3 formulas, right? Guys, go back to the identity sheets, or you can go back to my previous videos and you can see those 3 different formulas. In this case, in the last case, we used the sine square one. In this case, I'm going to use the cosine square one. So cosine 2 theta is 2 cosine square theta minus 1. That is one of the cosine 2 theta identities. But then we are not interested in theta or 2 theta. We are interested in theta over 2. That means if I reduce this by half, or divide this 2 theta by 2, basically reducing it by half, so then I will be left with the cosine theta on the left hand side. And then on the right hand side, obviously we can see the relationship here. When there's a 2 theta is a theta here, that means we are dividing this 2 theta by 2, then we're dividing it into half. Same thing if I start with theta now, then this is going to be cosine square theta over 2. Okay, and then there's a minus 1. Guys, these two are basically the same identities. It's like here I have 2 theta, here I only have theta. And so when I compare this with this, then I got to reduce this by half, theta over 2. Now if I look at this guy right here, and then I look at what I want to try to figure out. So it seems like we just want to isolate the cosine term, right? So to isolate the cosine term, we got to first start by adding 1 to both sides. This gets rid of this 1 on that side. So again, I'm going to bring this to the left hand side, because whatever we are trying to solve for, we want to keep it in the left hand side and everything else on the right hand side. So it's going to be 2 cosine square theta over 2, and this will be just simply 1 plus cosine theta. Now we still want to just get the cosine theta over 2 by itself. That is what the identity actually is. So we got to do a few steps. Got to first divide by 2, right? Once we divide by 2, this crosses out. We still need the cosine theta over 2 by itself. Now we have to get rid of the square. To get rid of the square, we got to take the square root, or take the radical on both sides. So when I take the radical on both sides, we know this square and radical crosses out. So we'll get cosine of theta over 2 on the left hand side. That's exactly what we were actually looking for. And on the right hand side, keep in mind we have to keep the plus and minus. 1 plus cosine theta over 2. Guys, this is the identity, and then we can bring it back here. And in this case, we actually discovered the identity. But even if like it was already given to us, we could actually verify it, okay? So it's plus and minus square root of 1 plus cosine theta over 2. This is the other identity. Guys, again, I keep on saying this. You don't have to like really try to remember all this. You will be able to use a formula sheet to work on the problems. But eventually, I feel like once you start doing these problems, or when you start looking at so many different problems, you will eventually like remember a lot of these formulas. But till then, just keep using the formula sheet, but try to understand the how we derive some of these, okay? Because in the next section, there's going to be like a lot of these examples where we have to derive. So we have to do a lot of mathematical manipulations, use the identities, use the algebraic skills that we have learned in pre-calc and other courses, and verify and prove things, okay? So guys, again, plus and minus, cosine could be positive or negative depending on which quadrant it is. We know cosine is positive in the first quadrant. Then well, let me actually show you like how we used to remember when we started learning these things, how we used to remember where the cosine is positive and where all the other trig functions are positive or negative. So guys, this is how we used to remember it. So back home, like I'm from in India, we used to remember it like this. So they used to tell us like add sugar to coffee. So add means like all are positive in the first quadrant. Sugar means the sign, and and its opposite, the cosecant, is positive here. And then add sugar to. 2 means like tangent, and cotangent is positive here. And then the fourth quadrant is C, which add sugar to coffee, and coffee is in this case is the cosine, and the secant are positive here. Okay, guys, in United States, like we like to think of this slightly different. And I really like that a lot. So I like to think of this as all students take calculus. And calculus is like one of my favorite subjects to like as a student and also as an instructor. So I like to think of this as all students take calculus. Guys, it's up to you which one you want to use, add sugar to coffee or whatever. But this is how we used to remember it. And this is how I still remember this, like which is positive where. So all the trig functions are positive here. Only the sine and the cosecant is positive. Everything else is negative. In this third quadrant, tangent and cotangent are positive. Sine and cosine and everything else is negative. Here, fourth quadrant, only cosine and secant is positive and everything else is negative. Okay. So guys, I mean, you can use that. If you have your own way of remembering things, that's totally fine. But this is how I remember where they are positive and where they are negative. Okay. So guys, that is cosine of the half angle. In my next video, I'm going to talk about the tangent of a half angle, and then we will write all of those up here, and you may have them on your formula sheets, and then we'll try to do some probably few examples on this. I'm not a super big fan for like double angles. I mean, they are useful, so that's why we're looking at them, but we're not going to look at like so many different examples. We'll probably do 2 examples so that you can see like how they are used to actually solve these problems, and then we'll move on to something more difficult, something more challenging actually. Okay.